Good morning, guys. This is Dr. Balakrishna, Associate Professor of Chemistry, Lendi Institute of Engineering and Technology. So, in the previous class, we have discussed about liquid fuels, where we have gone through what are the different kind of liquid fuels, what are the properties, what is the uses of those fuels, by taking an example of a lubricating oil, right? So now we are going to discuss about a new topic comes in the fourth unit as second part, which is fuel technology. What is that? Fuel technology. The name itself, it is saying that how to extract a fuel, what kind of technology used in extracting the fuel, what kind of technology is used in selecting a good fuel. Such kind of important topics are discussed here, right? You are all know that nowadays petrol or gasoline, diesel, kerosene, lubricating oils, tar, they are taking a crucial role in our regular life. So let us discuss about fuel technology, how technology is interacting with the fuels, how technology is applied for fuels. That is our today's concept. Before going to enter into the concept, let us see what is a crude oil. Crude oil, it is also nothing but petroleum. Petro means rocks, oleum means oil. So petroleum combinedly known as rock oil. So petroleum or crude oil is obtained in Earth's crust. In Earth's crust, right? So generally, where fossil fuels or the carbon rich containing materials present in the Earth's crust will interact with the minerals present in the soil under temperature and pressure, then they form a carbon hydrogen chain, right? They form a carbon hydrogen chain. So that is nothing but a CH chain, right? So the obtained product after interacting with the minerals with carbon and hydrogen containing materials, okay, they produce a substance is nothing but crude oil or petroleum. So petroleum contains carbon and hydrogen. The carbon and hydrogen chain may be olefinic, straight chain paraffinic, cyclic paraffinics, or aromatics. Okay, that depends. Along with carbon, hydrogen, oxygen also will be present there, sulfur also will be present there. Right, guys? So the major constituent will be carbon. So if you see the obtained crude oil, that crude oil is containing different kind of hydrocarbon chain, right? Yeah, now what we want to do is we want to utilize that crude oil in a proper manner, right? So how to utilize that in a proper manner? Crude oil, it is a mixture of all. So we want to utilize it in a proper way by fractionating it. by fractionating it, right? So the process of fractionating the crude oil into useful products is nothing but fractional distillation of crude oil. What is it? Fractional distillation of crude oil. So let us see. What is a crude oil? It is a high viscosity greenish brown color liquid. A high viscosity greenish brown color liquid containing carbon and hydrogen chain, where the carbon hydrogen chain may be olefinic, right? Aromatic, okay, aliphatic, cyclic paraffins or straight chain paraffins, right? Now our aim is to use that crude oil into useful products by converting that crude oil into different fractions, and after converting the crude oil into different fractions, the fractions to be used in a proper manner for our general life, daily life. Okay, the process of converting crude oil or petroleum into useful products or fractions is nothing but fractional distillation. Fractional distillation. So in that fractional distillation, initially take crude oil, right? Initially take crude oil. This is crude oil. Now apply 400 degrees Celsius temperature onto the crude oil with the help of heating coils. This is, okay, this is heating chamber, where the chamber contains coils. With the help of the coils, we are able to apply 400 degrees Celsius temperature, right guys? So when the crude oil is subjected to 400 degrees Celsius temperature with the help of heating coils, now it become into vapors. Okay, now the crude oil vapors are moving through heating coils and then enter into a long cylindrical tube. Okay, this is called fractionation column. This is called fractionation column. The fractionation column consists several what it is called trays, several trays, where every tray contains chimneys, allowing the vapors to move upward. Now, when the crude oil is subjected to 400 degrees Celsius temperature with the help of heating coil, then it becomes into vapor. Now the hot vapors enters into the fractionation column. This is crude oil vapors. Okay, they are slowly moving towards upward direction through chimneys present at each tray. When they are moving slowly, okay, towards chimneys present at each tray, they lose some amount of heat. When they lose some amount of heat, then they become condense, and they will condense and then become into liquids, right guys? So when the crude oil first is subjected to 400 degrees Celsius temperature, now the crude oil is in vapor state. Now the hot conditioned vapors enters into the fractional distillation column. Okay, where the hot conditioned vapors are moving upward direction through chimneys presented at the trays. When they are doing some work, they lose some energy. Here they lose some amount of energy in the form of heat. So what happened is, the temperature of the vapors reduces. now it will not be at 400 degrees Celsius temperature. They may be at 380 degrees Celsius, 390 degrees Celsius, or 350 degrees Celsius, right? So when the temperature reduces, some fractions present in that vapors, okay, some fractions present in that vapors at the level of temperature, that may be 380 or 390, they will become into liquids. Those become into liquids can be obtained here, right? So we have removed one fraction with respect to its boiling point. Now the rest of the vapors are moving towards the next tray, okay, and entered into chimneys where they travel some distance, right? They travel some distance, means they did some work. So again they lose some amount of energy in the form of temperature. So the temperature again reduces to 380 to 350. At the level of temperature 350, the other fractions present in that vapors will become into liquid. They can be obtained here. Now the rest of vapors moves upward direction, where again temperature decreases. At the lower temperature, the other fraction become liquid. They can be collected here. Again the rest of vapors moving upward direction through the trays, okay, through chimneys, okay, they lose some amount of heat, okay, in the form of energy, okay. At that lower temperature, the remaining fractions will become into liquid, okay, they will be collected here. Likewise, when the vapors are moving from the lower tray to upper tray, at every point some fractions are becoming into liquids and can be collected through a specific provision, okay. So what we are doing is we are separating the fractions present in the hot conditioned vapors of crude oil with respect to their boiling points. Finally, okay, we will get gases. Why we are getting gases? Because there the gases will remain as gases, okay, there the gases will remain as gases because condensation will not take place. Excuse me. There the condensation will not take place here. Why the condensation is not taken place there? Because the respective temperature is not reduced, okay. If furthermore I have reduced the temperature, if furthermore I allowed the gases to travel, then there may be a chance of getting these uncondensed gases into liquids, okay. Yeah, so initially I have taken a crude oil, 400 degrees Celsius temperature is applied, the hot conditioned vapors are moving through the coils and entered into fractional distillation column, okay. Thereby they are traveling through the trays, okay, which is having chimneys, okay. Then they are losing their temperature. At the reduced temperature, some fraction will become into liquids. Likewise the process is taking place. Finally we are getting uncondensed gases, we are getting gaseous molecules. So gas is entered, again we are getting gas finally, okay. Uncondensed gas means there the fractions kind of methane gas, there the fractions kind of methane gas, okay. I will tell it very clearly. When you introduced crude oil, it is rich of carbon and hydrogen, made into vapors by applying 400 degree Celsius temperature. When it enters into the fractional distillation column, initially some components will become into liquid. The one who become into liquid first will get decant here, okay, we can collect that is called heavy oil. The rest of the vapors are moving through the chimneys present at the each level of tray, okay. In this case, firstly we will get lubricating oils, after that diesel oil, next kerosene oil, next naphtha, next gasoline or petrol, next petroleum ether, finally uncondensed gases. If you see, the one who first come in the fractional distillation column is heavy oil. Okay, initially the temperature of the crude oil is 320 to 400 degrees Celsius. When the vapor enters into the fractional distillation column at the level of temperature 400 degrees Celsius temperature, okay, in between 320 to 400 degrees Celsius temperature, some fractions of crude oil will become into liquid, right? Which fractions will become into liquid? That is the question mark. Okay, so I am saying heavy oil is a fraction that will be converted into liquid at 320 to 400 degrees Celsius temperature, because it is rich of carbons. It is rich of carbons, where the heavy oil contains the carbon number varying from C17 to C30, where when the carbon number is high, the boiling point will be high, right or not? When the carbon number is high, obviously the boiling point will be high. Next, when the lubricating oil, when the crude oil is, okay, again moving towards upward direction through the trays, through the chimneys, then work done by the gaseous molecules, so it loses some amount of energy, right? When it loses some amount of energy in the form of heat, the temperature reduces. At the reduced temperature, at the level of reduced temperature, okay, we will get another fraction into liquid, okay, that is nothing but lubricating oil. The lubricating oil will be obtained nearly, okay, 280 to 320 degrees Celsius temperature. What is that? 280 to 320 degrees Celsius temperature, where the carbon number will be C17 to C25. So if you see, if carbon number, the one who's having carbon number is highest, they will first become into liquid. Got my point? The fractions which are having rich carbon number, okay, will become into first, right? Why? Because they will have high boiling points. The high boiling point fractions will become into liquids first. Heavy oil is having C17 to C30 carbons, means it is having high boiling point, okay, that is very close to 400 degrees Celsius. That's why they become liquid first. After that, lubricating oil become into liquids. After that, diesel. See here, diesel become liquid at 250 to 320 degrees Celsius temperature. What happens here? The temperature 400 degrees Celsius reduced to 250 to 320. Why? It loses energy in the form of heat. That's why the temperature reduced. At that reduced temperature, some fractions obviously become into liquid. Which fractions become into liquid at the level of temperature means diesel is the fraction. Okay. In this case, the diesel is containing C10 to C18. So if you observe with heavy oil, there the heavy oil is containing C17 to C30. But in the case of diesel, it is containing C10 to C18. The carbon number is decreasing. When the carbon number is decreasing, boiling point will decreases, because heavy oil's boiling point is at 320 to 400 degrees Celsius temperature. But diesel oil is having boiling point at 250 to 320. If you see the procedure, okay, it will be like after that if the vapors are moving towards upward direction, okay, the temperature furthermore reduces to 180 to 250. At the level of 180 to 250 we will get kerosene oil, where the number of carbons are with kerosene is C10 to C16. Furthermore, if the vapors of the oil, crude oil, moves upward direction, the temperature again reduces to 120 to 180, where we will get naphtha. Naphtha contains C9 to C10 carbons. Okay. Next one is petrol. Petrol contains C5 to C9 carbons. Okay. Its boiling point will be 40 to 120 degrees Celsius temperature. Next one we will get petroleum ether. Okay. Where the boiling point is 30 to 70 degrees Celsius temperature. Okay. Where the number of carbons are C5 to C7. Finally, we will get uncondensed gases. Okay. So they will not become uncondensed. That means they didn't condense into liquid. They will be present as gaseous molecules only. Okay. Why? Because they are containing less number of carbons. When they are having less number of carbons, their boiling point will also be very less. Okay. Here the gaseous molecules become uncondensed means we didn't reach the boiling point of the fractions present there. Okay. Next, if you see another one, this is what residue, asphalt, tar. Okay, when the crude oil is subjected at 400 degrees Celsius temperature, okay, we will get a residue, okay, or tar used in roads, right? Okay, where the number of carbons are C30 or more than that. Okay, they are having the boiling point is about 400 degrees Celsius or more. So this is all about fractional distillation of crude oil. So the main concept of fractional distillation of crude oil is crude oil has to be used for different purposes, for which we need to fractionate the crude oil into different fractions or different products. Then, sir, how to convert the crude oil into different fractions? There is a way. Okay, in converting the crude oil into different fractions, okay, it cannot be done with our hands or knife or something else. Okay, we need to do it chemically. Then how to do it? Okay, apply temperature, make that crude oil into vapors, and allow the vapors to pass through fractional distillation column. When they are moving in the fractional distillation column, step by step, they do some work. Due to the work done by the gaseous molecules, they lose some amount of energy in the form of heat. When the heat amount is reduced, some fractions will become liquids. So crude oil can be converted into different fractions with respect to their boiling points. That is the basic principle of fractional distillation of crude oil. Fractional distillation of crude oil, basic principle is crude oil is converting into different fractions. Okay, crude oil is converting into different fractions with respect to their boiling points. So when the crude oil converted into different fractions with respect to their boiling points, after the completion of the whole step, we will get some fractions, kind of tar first, after that heavy oil, after that lubricating oil, after that diesel, after that kerosene, after that naphtha, after that gasoline, after that petroleum ether, finally uncondensed gases. So simply converting crude oil into the products, basing upon their boiling points. through fractional distillation column. Through fractional distillation column is nothing but fractional distillation of crude oil. Understand? Kindly note down this. Okay? Thank you. Kindly switch off the